All right. Hi, everyone. I'm Charles, and I'm really excited to host this workshop on the introduction to generative AI and AI agents. Today, we'll be having a high-level conversation on what large language models are and how they relate to AI agents. We'll then compare the two and discuss the strengths and the weaknesses of both. Then we'll start to explore different ways we can construct different workflows and mechanisms that use AI agents and maybe different use cases as well. And at the end, we'll end with a quick coding exercise where we'll construct an AI agent. Then we'll give an agent and an LLM the same task, and then we'll compare responses and see which one we like more. And so you'll get exposure to LLMs and agents, and you'll also get exposure to the different kinds of frameworks that are available as well. And so just getting things started, what is generative AI? I feel like when we talk about this, what first comes to mind is like ChatGPT and maybe other AI models like Google Gemini or Anthropic's Claude. However, broadly, generative AI is essentially a lot of different media that is trained on a model. The model understands the different patterns and relationships between the different kinds of media. And at the end, that generative AI model, is able to produce media that's similar to the information that it was trained on. The reason why I use media is because generative AI models aren't only able to produce text and understand text and produce text. It also includes things like images, video, and audio. I'm sure you've seen I think it's called Stable Diffusion or OpenAI's is Dolly models that produce images. And so when we think about generative AI, it's not just inclusive to text generation, but it's also inclusive to those four things as well. And I feel like a lot of models today are multimodal, meaning they're able to take in different kinds of media, text, images, video, audio, and make sense to generate, whether it be text or images or other kind of media as well. And so the point I'm trying to make is GenAI includes those four things. And for today's focus, we'll be talking about text. And so the next point is large language models. What are LLMs? Essentially, LLMs are trained on a large corpus of text. The model is able to understand the different relationships between certain keywords and maybe certain sentence structures, and they're able to generate information or text that's very similar to the information that it was trained on. And a lot of the time, LLMs are trained on the entirety of the internet. And so if we were to train a LLM on the entirety of the internet, which includes things like websites, blogs, textbooks, video transcripts, training the LLM on everything in the internet up until 2022, that's the only information that's going to be able to pull from. And so if we ask the LLM a question about something that happened in 2024, because that information is not accessible and was not present in the data that it was trained on, it's not going to get an accurate response. In other words, it might hallucinate. And so if you use ChatGPT before, which probably many of you have done, the kind of normal workflow is that you give the model a text-based prompt, and then the model processes it and it gives you a response. And afterwards, you take that response into consideration to generate your next prompt. And a prompt is just in this context, a prompt is just text that outlines the instructions and tasks that we want the LLM to produce. And so the main thing I want you to take away from this is that LLMs are able to generate text, and the information that it's able to generate is largely based off of the data that it was trained on. And so one way that LLMs kind of struggle and might hallucinate pretty often is when you try to ask the model things about domain-specific knowledge or information that's locked behind an organization. For example, if you ask the LLM about a really specific acronym at your company, then it might not give an accurate response because that's like information that's not publicly available and hence isn't in the data that it's in the training data. And so there's this knowledge gap present. And there's this knowledge gap present, but also that workflow is really dependent on the human. Human gives a prompt, model gives a response, human gives a prompt, it's that back and forth. And so it lacks a lot of autonomy. And so those two problems are addressed through AI agents broadly. Essentially, an AI agent is made up of three main things: a large language model, an initialization prompt, and data and tools. The initialization prompt, that's just a prompt that the human would give in an LLM. It outlines the expectations and tasks and behaviors that we want the LLM to assume. The LLM is going to be able to reason, or it's going to be able to understand natural language or text and generate text in the response as well. We also know that LLMs are really good at being able to follow context, meaning they're able to follow instructions. They're also able to keep up a conversation as well. And they're also able to handle ambiguity relatively well as well. The new part are the data and tools. We know that LLMs kind of struggle with that knowledge gap, and that data or the information that they have access to is locked behind the amount of data that it was pre-trained on. And so what happens if we give a software entity that has access to understanding text and also has a set of instructions? How about we introduce new information to it? In other words, an AI agent is going to be able to have access to things like APIs and databases or new information to make the response that the agent is able to give be more tailored and helpful. Another way to think about this is through Barbies. So we know that Barbie is like the regular Barbie. We can assume that she's just a regular person who has a lot of schema and general knowledge of the world. However, there's also astronaut Barbie that has a degree in aeronautics and has a really specific toolkit and access to maybe like rockets. We also know that there's maybe a computer scientist Barbie who's really good at object-oriented programming and breaking down complex tasks. And there might be a journalist Barbie who's really good at being able to synthesize information from a lot of different sources to write up a really detailed and informative report to a broad amount of audiences. And so we know that those special kinds of Barbies have access to different tools. And similarly, those special Barbies have different instructions and they're looking at problems from a different lens. I'll talk more about this later, but you begin to see the importance of being able to have different Barbies to do different tasks. In other words, maybe we're at NASA and we want the Barbies to launch a rocket up to the moon. We'll need a computer scientist Barbie, a rocket scientist Barbie, and also a journalist Barbie to be able to communicate to the general audience what they're doing. All of them are tackling the same bigger problem, but they're breaking it down into logical, smaller tasks and delegating it to people or Barbies that have the skill set and context and set of instructions that is tailored to them. And so that's just an example of AI agents. I'll give another example in a little bit, but here's a nice diagram that kind of displays the data access of LLMs and AI agents. Again, LLMs are kind of locked to the information that they have access to, and it's locked behind the data that it was trained on. For example, like we can't ask an LLM that's trained on information up until 2022 we can't ask that 2022 model a question on something that happened in 2024 or 2023. One way that we could bypass this is by introducing more relevant and new data to the LLM and that LLM is now fine-tuned. And similarly, an agent can be given a large language model that is not fine-tuned or fine-tuned. And so that's why it's like both. And similarly, we can also give agents access to tools like APIs or databases to run software to get more information about the task that it was given to. And so data access is really important because depending on your task, you might need more relevant information. And so here's another example. Let's plan a vacation. Uh, and so we'll compare the response of an LLM versus a agent-based system. And so for an LLM, we, as the user in text, give preferences. For example, when in the year do I want to travel? Do I like hot or cold climates? What kind of food do I want to eat? Is it like a touristy vibe? And also, what's my budget as well? And so I'm giving my user preferences, I'll give it to the LLM and we'll get a very generic response. The LLM doesn't have access to my maybe like a Google Drive spreadsheet that includes how many vacation days I have and when I'd be able to take them. And similarly, the LLM doesn't have access to the internet. And so internet at that time. And so maybe a restaurant opened up within the past month. The LLM isn't going to be able to access the internet or maybe like Yelp to get reviews on real-time data. Let's contrast this to AI agents. Given the same information as the LLM, for example, user preferences and budget, let's break down this complex problem of planning a vacation into three main agents or three main stakeholders. We can have an agent that's looking at this problem through the travel lens, another one through the itinerary lens, what they're going to do at the destination, and also through a budget lens as well. All of them are looking at the same problem through different lenses, and all of them have different tools or software they could run to help solve their unique task. For example, the travel agent might have access to an API or a database on the like flight times and when in the year is less touristy or when there's a lot of tourists at different locations. Um, the itinerary agent will also look and maybe get information from the travel agent on the destination. And at that destination, the itinerary agent can scrape things or can search up things with Yelp or Google to understand what are things to do there. All right, I'm going to go swimming or I'm going to go skiing. And similarly, the budget agent will also be able to understand, like, all right, this is all really cool, but like, what's my budget? Is this realistic? And if it's not realistic, let's look at alternatives. Let's search the internet for maybe a cheaper hotel or a place that has cheaper food to give. And so these agents will work together to help solve this complex problem of planning a vacation while also introducing new information through using software tools like APIs or running functions like code. And at the end, the result we get is a really tailored and personalized travel plan that is better than a very generic response. And so let's dig deeper on the differences and similarities between the two. We know that LLMs are very reactive, meaning you have to give in it's that back and forth interaction you have with the LLM. There's a lot of human input and it's not autonomous. However, AI agents are able to take the prompt once from the user and afterwards iteratively improve upon the responses and able to give a detailed response that is very tailored to user preferences in a way that doesn't require the user to be at every step. We'll talk about it later, but there are different ways that we can introduce, or there's different ways that we can construct AI agents to work. And one of those ways includes human in the loop feedback, but broadly, AI agents are more autonomous and require less human feedback. Again, LLMs are fixed on the knowledge that they're able to access. However, we can address this through fine tuning. An AI agent, again, it's made up of a large language model, an initialization task and or initialization prompt, and also maybe different software tools like APIs or access to a database or anything like that. And so the AI agent can use the pre-trained model that's very generic, or it can use a fine-tuned model that is, for example, maybe domain or task specific. And so LLMs are really good at like zero-shot prompting, or in other words, LLMs are really good at doing tasks that don't require breaking down, or LLMs are really good at simple tasks. However, they struggle at very complex tasks. Uh, Contrasting this, AI agents are able to break down complex tasks into smaller tasks that can be delegated out. Another way to think about it is like, all right, you're in class and you're given an assignment to write an essay that's 600 words. Uh, a way that an LLM would approach this was it would just uh, start writing without thinking about the introduction or conclusion paragraphs or maybe a thesis. However, an AI agent will break down the prompt, understand important parts that should be included in the different body paragraphs, and only then, after planning and breaking down the prompt and understanding the objective of the writing assignment, that it will begin writing. And so an LLM is going to give a really kind of bad response, but AI agent's able to make it more tailored and better. And even though it takes up more time to do, it's still going to be better. And so here's some similarities between LLMs and AI agents. Both run the risk of hallucination because they both use large language models. And so, for example, all of the biases and incorrect information that's present in the internet, that information is still present in the models that are trained on. In other words, biases and incorrect information, that's still in the training data. And so it still might be present in the information that, or in the text that these models generate. And so that's something to be specific, or that's something to be considered about, especially for domain specific tasks that are really niche or require a lot of that other like won't be really good. For example, like a really hard math problem. Similarly, both cost money to run, depending on your model or depending on the size of or the amount of information that you want the model to consider. That takes tokens. And if you want a really long response, it's going to cost more money or tokens. But if you want a small response, it might be less tokens or less money. However, when we think about AI agents and how they're able to autonomously work together and really have a back and forth conversation with each other without a human intervening, we can assume that costs are going to start to pile up. And similarly, as whether it be an LLM, as, for example, if you might have used ChatGPT, like if you have a long conversation, you're trying to learn a really difficult and complex problem, and you have a lot of back and forth with ChatGPT, you'll start to notice that information that you gave the model at the start of the conversation might have been forgotten and not, might not be recalled in the newer responses that you get. And so that's called like context window limitation. And so that's a consequence of having a long conversation. There's different ways that we can go about managing context, but that's just something that's a risk that's shared between both AI agents and LLMs, and also reasoning gaps as well. LLMs are really good at being able to recognize different patterns in the text and data that it looks at. However, it's not actually going to be able to reason through something. The breaking down of the complex problem into smaller steps, that's and introducing software tools and new information that helps address the inaccuracies that might be present. However, nothing is sure, and you should use skepticism in reviewing AI generated work. And so, as I said before, for example, in the whether it be the Barbie example where we have a rocket scientist, computer scientist, and a journalist Barbie, there are different ways that we can construct how agents work together. Or maybe looking back at the vacation example, there's different ways that we can have the travel itinerary and budget agent work together. And those are called agentic workflows. And here are some of the workflows present. You can make it so that the agents work together up until a certain point, and once they meet a certain criteria, they'll then prompt the human to give input. Once the human gives input, that response will then be taken into consideration by the AI agents to then iteratively improve upon the response, making sure that the human acts as a quality assurance. We kind of mentioned this earlier, but tool calling agents can use like a function or an API or access a database to perform a certain function, perform a certain operation. For example, an AI agent who's like a math expert might have access to Wolfram Alpha's like API to be able to calculate an integral. And so an LLM isn't going to be able to do and isn't able to calculate integral well on its own. And so having a tool be able to do that is something that's of interest. Similarly, we can have multiple agents work together. In our previous example, we had three vacation planning agents work together. And similarly, breaking down complex problems into smaller tasks and then delegating those tasks to other agents that can be a planning agent or a planning workflow. And so here is a revised vacation plan agent-based system using the human in the loop workflow. And so once the travel itinerary and budget agents work together to come up with a draft of the vacation plan, it'll then feed it back to the human to review. The human will either be like, the human in natural text can then say, hey, I think this budget, or hey, I want to go to Cabo, but Cabo is really expensive and not really within my budget. Instead, I want you to give me a revised vacation plan that's still in Cabo, but has housing accommodations that are a little cheaper. And so the user will type in and give the feedback to the agents. The agents will then use that and take it into consideration and will generate a new revised vacation plan, which will give back to the user. And it can have this back and forth conversation until the user says, all right, this is amazing, and will then approve the agent to stop collaborating and finish its task. And so here's some other ways that we can do it too as well. Think about in a like corporate America or just like in general work, you might have a manager. The manager, I'm looking at the supervisor workflow right here, but say that there's a manager who helps orchestrate collaboration and delegates tasks to different employees. We can also have a supervisor agent be able to do the delegation and orchestration of collaboration as well. Similarly, just as your manager might have their own manager, there's a hierarchical architecture as well. And so there's my point in showing this diagram is saying that there's a bunch of different ways that we can construct agent-based workflows. It's really just dependent on the task that you're trying to do. This diagram is from LangChain. LangChain is a agent work or agent framework that you can use to construct agents and agent-based workflows. Here's another workflow that uses AI reflection. Essentially, the AI agents are going to review the AI generated response before giving it to the user. And so in this case, we'll generate an initial response, then we'll improve and tailor our response using like code or different API calls, and then we'll reflect and critically evaluate the initial response and identify different ways that we can improve upon it. We'll provide critique, maybe new criteria to evaluate the response that should be considered, and we'll iteratively improve upon that response until the reviser determines that it's good and it sends it to the user. Um, what what this agent uses as criteria for what's good and bad, that can be defined in the prompt of the LLM. And so you might have heard of like prompt engineering, but the quality of the instructions that you give to the large language model broadly determines the quality of response you get, meaning it should be specific and depending on your task, really tailored to what you're trying to do. Here's a plan and execute workflow, again from LangChain. The user gives a list of tasks and what we want the agents to do. The planning agent will then generate and break it down into different sets of tasks. We'll then perform those tasks here. We'll maybe access some tools to run code or API to get more information, API calls to get more information, and then we'll replan again and give it back to the user once everything's completed. And so it's iteratively improving upon responses. The user only gives input at the start of the workflow, and it only gets the response once it's clean and polished. This just highlights the autonomous part of everything as well. Here's just an example of an agent workflow I built for an internship, which is really cool. We could break down a energy supply and demand problem into 3 different stakeholders or agents, that being utility, market, and consumer. And essentially, we'll have one agent tackle and answer the prompt of the user. It'll then pass that information and answer to another agent, and then we'll pass it over again. And once we address and solve the different parts of the tasks that the user gave, and it's like really scattered, and a lot of different people or agents have kind of added their own touch or style to that final response. We can then have another agent kind of synthesize everything and make it really pretty and readable and easy to read and give it back to the user. What I'm trying to highlight in this diagram is that there's a bunch of different ways that we can construct how agents interact with each other. And it really is just dependent on your use case and what you're trying to do. Here's another example as well. Basically, the user gives a problem statement to a agent. The agent will then break it down into a list of agents that it would need to create, and then we'll then generate the tasks and descriptions for all of those agents. And then we'll actually run those agents to solve that problem. And then the user will keep getting feedback until it meets some arbitrary criteria to end and have a really polished response. And so this is just an example of AI agents are really customizable, and there's a lot of different ways that you can create agents. And it just kind of depends on what you're trying to do. And so how do you actually create these workflows? Here are some frameworks that are widely available, that being AutoGen, LangChain, CrewAI, and Semantic Kernel. Yeah, I think a lot of people use LangChain and I think it's LangChain and Semantic Kernel that a lot of people use, but that's just not me saying it. There's also a lot of industry demand for knowing how to use LLMs and agent workflows and frameworks. Here's a NVIDIA job posting I pulled like a week ago. Like LangChain, LangGraph. LangGraph is very similar to LangChain. They're all a part of the same creator or organization, and they all, LangChain and LangGraph integrate well to each other. Here's a machine learning co-op internship opportunity that uses LangChain as well, and you have to know how to use LLMs. Um, that's not to say that knowing only generative AI is enough to get a machine learning or data science position. It's not, but what I'm trying to show and highlight through these job postings is that know-how of Gen AI and LLMs and these kinds of frameworks is something that is worth learning. And so I'm going to stop the recording right now, but our next stop is going to, or our next task is to create an AI agent. We'll do that quickly. All right. And so now we're going to start. You'll first want to, um, let me actually update this link really quickly. You'll first want to join this link. Then afterwards, we'll just we will save a copy in Drive, create a copy. Great. And so we'll be using first we'll need to get our language model. Then afterwards, we'll need to sign up for a Tavily API account. And so you'll want to go on this link in your non-UCSD account. And once you're logged in, we're going to get access to an API key, which will let us get a language model. All right. We just use the Gemini API. So I already have one. So what I'm going to do is I will just copy it. Okay, so it's copied. We're just going to run this cell. And so while that's running, essentially what we're doing here is just we're setting up our environment, installing any packages or libraries that we need. And what we just signed up for is it's an API key to be able to call Google Gemini's or Google's LLM, Gemini. All right, so we'll run this. We have our API key copied here. Then we'll just paste it in. Good. And then next, we're going to have our Tavily tool. Tavily is um, Tablet is essentially we're going to sign up for it, but it'll basically just allow us to search the internet and use results that we got from the internet into our response. Okay, so you just want to sign in. All right, and so once you're signed in, we will copy our API key and put it in here. Great. And so Google API key, that's just our language model. Tavily is a tool that allows us to search the internet. And so we'll be giving our language model access to the internet to search up results. Again, why is that important? In certain language models, information that they're able, or in language models in general, the information that they're able to generate and what they know about is locked in the data or information in their training data. Again, this ongoing example, we train a model on the entirety of the internet up until 2022. It's not going to know information about info on 2024. And one way to bridge this knowledge gap is through using software tools. And this tool is able to give the LLM access to the internet. So really, really cool. This cell is essentially just setting up our tool. It's going to consider two max results, and this is the prompt that we give it. And so it's basically searching the internet for information on the weather in San Francisco. We're just running the cell to get a sanity check to make sure everything works. So that's the response. And then next, we're going to add some more specific functions or specific settings to our tool. Example, we want to consider like trustworthy sources that don't include harmful or dangerous content. Next, we'll set up our language model. LangChain uses a thing called a language model. Depending on the model that you use, it has a different set of parameters for each. For example, if we wanted an OpenAI, if we wanted to use the OpenAI API, there's an OpenAI language model. Similarly, for Google, there's the Chat Google generative AI language model. And so I think the only thing that's really important to know is that if you want to create an agent with a specific model, whether it be ChatGPT or your own local model, you just have to change the language model here. And all of them have their own different parameters, but mostly they're the same. So for example, Gemini, you need to include, or you can include some safety configurations as well. Cool. So we have our language model. Now let's give it a sample prompt to make sure that it works. And so, hi, I'm Charles. I go to UCSD. Its response, hi, Charles. It's great to meet you. Go Tritons. Awesome. Our language model works. And we also know that the search tool works as well. Let's put it all together. We know an AI agent is made up of a language model and initialization prompt in a tool. We have two of those things. We're putting together the model and tool. And next, we're going to prompt our agent. So we're just going to say, hi. And afterwards, we get a response. It says, hello, how can I help you today? And so what you're seeing right here is just the model or the language model, or sorry, LangChain, the framework kind of records everything, records the initialization prompt and some metadata, the ID of the response that just generated, and the actual AI generated response as well. And for any reason why, and if there is any reason why the response is cut off or the model isn't able to be run, it can give you certain finish reasons. For example, maybe you ran out of tokens, or another way to put it, maybe you prompted the model and it's not able to generate any more text because you've reached the limit. It'll say that. You can also say the amount of tokens you used as well. And so now let's ask our agent to use the search tool to find the current San Francisco weather. So we're going to ask about real-time information that wouldn't be in the pre-trained or wouldn't be in the training data of our LLM. And so this is a lot of information. Let's then compare it to just accessing the LLM that doesn't have access to the internet or a software tool. It's saying I do not have access to real-time information. And so this is a very generic response, while this is very tailored. That's not to say that longer responses are inherently better. Obviously, all of this might not be really relevant, but the point I'm trying to highlight is that LLMs or AI agents are able to get more information that is tailored and specific and helpful to the task that we're trying to solve. And so wrapping everything together, here's some key takeaways. LLMs are not the same thing as agents. LLMs are able to understand natural language and generate text, but they require a lot of human input. Agents break down complex tasks into smaller tasks and are able to act and implement those tasks autonomously without human intervention a lot of the time. Workflow flexibility, how we construct agents to solve these problems is highly customizable. You could think of them like Legos, where each like workflow that you can construct can complement another one. And it's very tailored to the use case that you have. And certain frameworks on how to create these AI agents are LangChain and AutoGen. And so I really hope you liked this workshop and that it was hopeful and that was helpful. Uh, I feel like AI agents are really important and are an emerging piece of technology. And I think it's worth at least knowing about them, if not getting hands-on experience with it all. And so, yeah, thank you for watching, and hopefully this is helpful.